We have been enhancing the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. It's time now to spice up the entire game by looking at certain variants which make the game very, very interesting. Notice here in my screen, I have a indication that this is a liar variant. Now, what I mean by this is, let's say I create 9 rows, 9 columns, and say 10 mines like usual. When I create the board, everything looks normal. But let's try playing this. When I do this, for example, now notice there are some zeros here, there's some twos and threes. Now, what this means is, I mean, the fact that this is a liar version means that, look, none of these clues is in fact correct. It's either one more or one less than the actual clue. So this is very interesting. Now think about it. Either one more or one less, which means that all these zeros are in fact one. So that part is straightforward. In fact, I've got a mine over here. This was also for me a one. Hence, this cannot be a mine. Now notice I have a one over here, which means that this is actually a two because one more or one less. However, this two, I can't be sure if it is one or if it's three. So let's move forward. This must be a one because zero is always a one. So I claim this as one. Now this three could be two. This three could be four because it's not three, right? It's one more or one less always. Now this two could be one or three. Well, in this case, we are sure because this is a one. That means this cannot be a mine, which means that this must have been a 1. Now here, I've got a 4 here. 4 is, remember, either 5 or 3. I would go with 3 because with 3 I can solve this. These two must be mines. And with this 3 in place, in fact, I can be quite sure this was also a 3. This was a 2. This was a 3. Because 1, 2, 3, right? And if this is the case, then these are not mines. Let me just click on these. Now here, this must be a 2 because 1, it's 1 here. I got 2 mines here. This is a 2. And if this is a 2, and this also must have been a 2 because I see 2 over here. This also must have been a 2. But if all of these are 2s, that means that none of these should be a mine. So I've got a 0 here, which means there's actually a 1, and I've already got one mine over here. So I can click. Okay, good. So this helps me. This must be a mine because 0 is always helpful. So 0 is basically 1. I've got a 2 over here now. Now this 2 could be 1 or it could be 3. Now it can't be 3, which means that this must not be a mine. And that, okay, so I have to be careful here. So this must not be a mine. My bad. This must not be a mine. Yeah, so this makes sense. So this is one mine here. Right? Notice this must also have been 1. This is also 1, right? So now let's come back to this. This must be a 2 because 1, it's either 2 or basically it's 2. And hence this must be a mine. This must be a 2 as well. This also then is a mine. And let's assume this was a 2, must be. Now we have some situation here. So this is either a 2. Okay, so let's start from here. This is 0, which means this must be a mine, which means this must have been actually 1. Very interesting now. This is this is 2 over here. So one of these is a mine, but this could be 5 or this could also be 3. So now this is very, very confusing. But let's go with this, right? So we have 3 over here. So this could have been 4. Can't be. In fact, this must be 2. So I'm going to go with, there's only one selected here. So I'm going to take this as a mine. If this is the mine, let's assume this was a 2. Hence, I would argue this is not a mine. Okay, so this is either a 3 or a 1. Can't be, can't be because it's 2 mines, so can't be 1. So this must be a 3. And then this over here could be 5 or could be 3, but most likely it's a 3. So I'm just going to take this as the mine, and basically this 2 means it's probably a 3, so I'm just going to assume none of this is a mine. Okay, let's see, and indeed I was right. Now you notice one twist of the rule and the entire game is so much more difficult to solve. So basically 0 gives it away, but everything else there's a doubt. It could be one more or one less. This is what we are going to build as the liar variant. Now once again, the way our code is written, in fact this is not very hard, but we have to be a little bit careful. So what I'm going to do is to first create a clear indication that we are playing the liar variant, so there's no confusion to the player. And then we are going to see how we will update the field but we change the way the display happens so that the game can go on, but the display changes. So important, to put all these things consistent. So I just get back to my project over here. I first create, let's say, a new frame here. So I call it, let's say, variant frame. Say variant frame, just to tell everybody what frame we are looking at. So variant frame is, well, tk dot say frame, and I just set this to variant frame dot grid. So remember basically we have row 0, row 1, row 2 for the entire game board, and then row 3 for the variant. So I'm just going to set this row to, let's say, so 3, and call equals to 0. Um, Now variant, so on this variant frame, I create a variant, let's say, label, and this basically is so I have to define this first, is tk dot label. Um, this must go into the variant frame. Text is going to be layer variant. Font is equal to, let's say, rather large, so I'll just make it Times New Roman 20 and say bold. And that should be about it, right? So once I do this, um, I can just pack this label, right? So variant label dot, let's say, pack. Now first let's see this working. So I expect this label to show up as you notice when I run this project, I indeed see a large and clear layer variant written over here. Now, in order for me to, enable this variant, I'm going to just define a variable up front. Let's say right in the very beginning, so that there's no confusion. I'm just going to set, well, layer, say, variant is equal to 1. Now, this is in the global scope, so I can use it elsewhere. Now remember, the main point is that the display number should be different from the actual field calculations, but the field calculation itself we wouldn't want to change because the entire game depends on that. So what I'm going to do is that in my function update field, which is here, I am creating the field over here. So basically the way it works is that for every location, for every mine location, we go in and look at the neighbors and update the field, which means at the end of this for loop, my field is ready. Now what I'm going to do is to define a new list. I make it global. So this is, let's say, called field display, so that the actual field gets, let's say, um, disconnected from this the displayed field. Actual field I wouldn't want to change because otherwise the game dynamics might break down. So I just create a new, let's say, display field. Now remember, I kind of want to copy the field, but I don't want to create shallow copies. I have to be careful. So I will create like a deep copy here. The way I'll do it is by just saying that, look, field, let's say, display is an empty list. So notice that field display is really kind of like a copy of the field list, but it's not a shallow copy. So we have to be a little bit careful. I'll do a little bit of explicit copying here, just so that I don't run into the problems of shallow copies. So I just go and say for arc kk in range, let's say n rows, field, say field, uh, field display dot append. So I'm appending an empty list. And thereafter for jj in range, let's say n calls, field display kk dot append, and basically I'm just going to append, let's say, field kk and jj is calls and kk is rows, right? So that should be fine. Now these two, at this point I expect the two lists to be exactly the same. Let's just verify this is the case. So I'm just going to say print field and also print, let's say, field field display. All right, so now when I run this, you notice I get a clear indication that this is a layer variant. When I try to, let's say, run this code with 10 mines, 9 cross 9 cross 10, I can make the screen a bit bigger and I get a nice, let's say, clear indication over here. You notice that the two lists are now exactly the same, right? So you can see it from here very clearly. Now, why have we created the second list? Well, because all the display that happens here will now be happening from the field display. Otherwise, the game will keep running just from the field. So that way, the game will not break. None of the loops will actually change. However, remember the field display is not entirely a copy of the field, because that really doesn't make sense, right? So in fact, what we need to do is that wherever there's a clue, I'm going to either add a +1 or a -1 in the liar variant. So what I'm going to do is that I'm just going to say, look here, for JJ and region calls. So if, let's say, field KKJJ is equal to, say, 0, or field say KKJJ is equal to 9. So if this is the case, well, no problem, make the field display same as the field, because these are not the clues, these are either zeros, empty cells, or mines. Else, well, I want you to not append this directly. Okay, so let's just copy this first. But I want you to randomly go and add a 1 or a -1 to this. So I could just do random dot choice and let's say -1 and 1. Now this -1, 1 is a list. So basically I randomly pick up an item and I, add that to the number that is on the field, right? So that will make the number becoming either 1 more or 1 less. Now obviously I do this only when I'm in the liar variant. So I'm just going to say, well, liar variant times this. Now notice liar variant is also an integer. So if I set the liar variant to 0, then this effect will go away. So that's the whole idea. Now, like I said, this is the field display. Now when I run this, you notice that, for example, here I had a 1, but my display field, this is 2. Over here, I had lots of ones, but, I've ended up with 2, 0, 2, 0, because it's either 1 more or 1 less. Randomly, this is happening. This 2, for example, has become 3. Now, with this set, all I need to do is that wherever, we are, let's say, clicking the board and the clues being displayed, instead of displaying from the field list, I will display from the field display list. So this happens in two places. First is when I click the button, any button that I click. So that is when I find that a field is non-zero. I just go and display, for example, from here. Instead of field, I just do it from field display. And also the colors will choose basis the field display. So again, very logical. The next place this happens is in the open up section when I hit the end of the, let's say where the recursion was stopped. So essentially that is this portion here, a non-empty cell when is what I reach. Like I said, the game, I mean, this we are not changing. We did not change the field. So, the rule of the game, the progression of the game will work exactly the same. Just at the display stage, I will make it field display. And this also will take it as field display. Really cool. So my liar variant is in fact set up now. If I make the liar variant equals to 1, when I now run this, let's make this bigger to start with. So let's say I say, well, 9 rows, 9 columns, and say 10 mines. I create this. Mind you, this is the liar variant. When I click on this, so I'm getting a 0 as white. We'll fix this later on. So I get a 0 here, a 0 here. This means this is a mine, because 0 basically means 1. So has to be 1 as well. This could be 2, or because yeah, this could be 2 basically. So if this is 2, this must be a mine. Now this could be 2 or 3. So we can't, well, this could be 2 or 1. It can't be 1. It has to be 2. So this must not be a mine. This must be a 2 as well. And there is a 1 over here. So if this is the case, well, then this must be a mine, because this also must be a 2. This is 1. So this is not a mine. Let's assume this is a 2. Now this could be very confusing. So 2 or 4. Well, could be 4. Who knows? But if this is 4, then I can't, I mean, this can't be 2. So, because this is 2, so which means that this is not 4. This must be 2. So, which means only one of this is mine. So, let's come from here. So, this is a mine. Okay, if this is a mine, then, well, I know this is also a mine. Now, this could be 1. This could be 2. If this is, but this can't be 3 for sure, right? So, it has to be 1. which means that this is not a mine, right? And now again, this could be 3 because these two could be mines, but this here can't be a mine, so which means this must be a 1, which means this and this must not be a mine. Now this is well, this could still be 3 because these two could be mines. Can they be? Because, but then, well, look, this is either a 4 or a 2. I've already got two mines here, so this is not a mine, which means this is not a mine. Okay, so things are opening up now. This is not a mine either. Now this could be 2. This here could be basically be 1 or 3. Okay, so now let's look at this. So this is either 2 or 4. So this must be 2. And I would say this is a mine here because couldn't have been 4. Now, if this is the case, this here is very confusing. 2 or 4. So I've already got 2 here and I've got this also could be 2. So if this is 2, this is not a mine. This is not a mine. So this could be, so now this here could be very, very confusing. So this could be 2 and I've already got 2 mines here. So let's assume this is not a mine. So this could be 2 or 4. But then I've got a 3 or a 5. So can't be 5, can definitely be 3 because so this could be a mine, could not be a mine. So if this were a 1, then this must be a mine. Yes, so this must be a mine. If this is a mine, then I assume this is a 2, so this 3 is done. And assume this is a 1, we can take a chance that this is not a mine. This could be 2, I think we take a chance this is also not a mine. So I think we are good so far. Over here, now this could be, let's say this is 1 here. This could be a 2, I would think. So this must be a mine. And this was also a 2, so these 2 is fine. Now this must be, could be a 2. Okay, so if this is a 2, then, well, this definitely can't be 4, so this has to be a 2, which means that let's assume this was, so this could be a 1 or a 3. Can't be 3, so it has to be only 1, so that means this is not a mine. This here could then be 2, so this must be a mine. So this must be a 3, let's assume so. This must be 1 because can't be 3, so this must be a 1, so which means that this cannot be a mine. This helps me, so 0 is always helpful here. So this now must be, so I've got, in fact, I've got all the mines detected, so I just have to be careful. I've got them all correct, right? Took me like almost 4 minutes to do this, right? So here, so if this is, so now it can't be 3, this must be a 1. I'll go with this not being a mine. And fantastic, I managed to solve it. Really, really, really amazing. And how the game becomes so hard with just one twist, right? Now the reason this is appearing white is because of our list. The colors list, I can make this magenta or something which is a bit more visible. And that should fix the thing, right? So I just get back to my colors list here. Right now notice it's a white, but we can make it magenta. I hope this was interesting to you. See how we created this variant without disturbing the fundamental structure of the game, and that is always an important consideration. I hope you found this interesting. We have many such activities on our website. Look at www.ybyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.